Middag allemaal. Wat een goed moment om te zien hoe vol de zaal is en hoe iedereen gekomen is. Namens het bestuur van de ME-CVS-vereniging wil ik jullie van harte welkom heten. In het NH-hotel in Utrecht, met alle bouwactiviteiten eromheen. Dus sommige mensen zijn wat later, daarom zijn we wat later begonnen ook. Het programma ziet u hier achter mij op het scherm verschijnen. Een speciaal welkom voor Linda en Don Tannenbaum. Gisteren waren ze nog in Londen voor een congres over ME en vandaag bij ons om te spreken over de Open Medicine Foundation en over het wetenschappelijk onderzoek wat daar plaatsvindt. Even spieken. Het gaat vooral over de samenwerking op het gebied van wetenschappelijk onderzoek en het versnellen daarvan, zodat ook sneller een diagnose gesteld kan worden in de toekomst. Een speciaal welkom ook aan Ruud Vermeulen en zijn vrouw. En Ruud al naar de... We hadden een discussie, een heel klein discussietje over en zijn vrouw, ja. Hij zal na de pauze spreken over inspanningsintolerantie en testen, wat nog wel een belangrijk onderwerp is en ook in het recente rapport van de Gezondheidsraad naar voren komt. Na zijn speech kunt u hem ook vragen stellen, net als na de speech van Linda trouwens. Er zijn geluids- of videoopnames van de speech van Linda en van Ruud toegestaan. Maar tijdens de vragenronde en voor en na de vragenronde voor en na de presentatie mag er niet gefilmd worden of gefotografeerd worden in verband met de nieuwe privacywetgeving, waar we ook nog een beetje aan moeten wennen van hoe doen we dat allemaal. Deze middag wordt afgesloten met een uur waarin u allemaal de gelegenheid hebt om elkaar te ontmoeten, maar ook Ruud en Linda en Don. De koffie, thee en water staan daarbij de hele middag gratis tot uw beschikking hier op de gang. Dat hebt u allemaal wel gezien. De dia voor Linda. De PowerPoint die Linda heeft gemaakt is vertaald in het Nederlands. Dat is om het voor jullie makkelijker te maken om haar speech te kunnen volgen. En die ligt, als het goed is, voor u op tafel, hebt u kunnen zien. Samen met nog wat informatie over de Open Medicine Foundation. En na deze bijeenkomst zullen wij deze ook beschikbaar stellen door middel van een link op onze website en onze social media. En we hopen daar ook zo spoedig mogelijk links te zetten naar video's die zijn gemaakt. Zo spoedig mogelijk betekent soms even wachten. Linda is zelf moeder van een dochter met ME-CVS. Ze was in 2016 16 jaar oud en werd van de ene dag op de andere dag ziek. Samen met Don begon zij een fonds ten behoeve van onderzoek naar ME, zoals ze haar dochter had beloofd. Ik geef nu Linda het woord, want die kan er beter zelf over vertellen. U kunt dus de PowerPoint volgen in de Nederlandse vertaling van de dia's. Linda.
Thank you all for coming, and I really want to thank MECFS for organizing this. It's incredible what they've done, and been able to invite everybody to come, and very excited to see and to meet everybody. And I know it takes a lot to organize something like this, so thank you very, very much to the organizers as well. And I will try to talk slowly. I'm sorry I have to speak in English. We translated our PowerPoints, so afterwards you can take a look at some of the things that we're talking about. I'm planning on going over a number of research that we're doing and give you a research update mostly. And so some of it will be technical and some of it you can read a lot more about it on our website and we'll fill you in. So before I start, I wanted to ask, if I may, and if you'll share, how many of you are actual patients that are affected with this horrific illness here? So about half of you. And how many of you are parents and family members? Well, thank you very much for coming, and thank you for all the supporters that are here to learn what we're doing. And as you know, my husband Don and I are parents, and we started this foundation because we're desperate parents looking for answers, as you all are. And we realized that really nothing was happening out there, so we figured we better step up and start doing something. So we really have gotten together the whole international community to help us with this effort, and many of you here have been supporters in helping with our efforts and following what we're doing, and we really appreciate that because it takes a whole world to figure this out. And truly, it's all over the world. We have over 100 different countries signed on to find out research updates with us. So it's everywhere. And even though you feel like nothing's happening here and there's no doctors and no research happening here, unfortunately, it's really that way most of the world. So we're really trying to bring people together and have people collaborate and talk and openly share results so that we can really find out some answers and help our loved ones get their health back. So that's the plan then, the mission that we're all on. So I want to, maybe I should, I think, if you wouldn't mind, I'll just stand over here with the mouse.
Okay, no problem. Yeah.
Just so I can,
Okay.
because I'm going to flip through some of these I'm going to flip through quickly. I want to spend more time with you to talk about the research. I've been giving these talks to many different audiences, and many of the audiences are people who don't know anything about this disease. So of course I go through the whole disease process with them to make sure that they understand before leaving that this is a real disease. But I know the audience here, so I'm not going to spend time on that. So I'm going to flip through a few of these slides that I don't need to do. My next talk that I'm giving is in Italy, and that particular talk is with journalists and physicians. So we'll be going over extensively all of the medical symptoms and all, but I will skip this. And obviously, you know, it's a major health crisis all over the world. And there's still no FDA-approved treatments, so that's one of the first things that we're going to start working on this year, and try to start doing some pilot treatment trials as well. And of course, we're looking for a diagnostic test. And some of these slides just show you that our CDC, our government, our CDC, our NIH are fully knowledgeable that this is a severe disease, even though the doctors don't know and they don't give very much money for research. They've known in this case since 2006 and announced that the disability is worse than MS and AIDS and end-stage renal disease, but they're still not giving much money to it or attention to it, but they know it's a disease. And we had the Institute of Medicine report come out in 2015, but again, they did a 1.5-year study of this and found out and came to the conclusion, of course, that it's a serious disease. So I don't need to tell anybody here in the audience about these symptoms, so I'm going to skip over these symptoms. Usually when we get patients together, we make a list of over 60 different symptoms. So we know that people have different symptoms, but many, many people have these same symptoms, which really help define the illness. And that's what we tell people that know nothing about this. So many of you may know that the director of our scientific advisory board has a very severe son, a very severely ill son. His name is Whitney, and he is one of the very severe. He doesn't communicate. He can't have light or sound, and he can't eat. And so he is the son of Ron Davis, who is directing all the research that we're doing and has pulled together this tremendous team that we're working on. And so him and I, as parents on a mission, are doing everything we can to find answers, and that's the only reason that we're doing all this research. I don't need to go over the impact with you, so I'm going to skip this. So our goals as a foundation is we're a neutral foundation, meaning we can fund anybody's research that our scientists decide to fund. So we're not attached to a university. We actually are working a lot with Stanford, as you know. We're just opening up a collaborative research center at Harvard. We fund research in Sweden. We fund research in different universities. And we're really trying to get everybody to do research and to share research and to share their results. So we're all looking for a diagnostic tool, effective treatments, prevention, ultimately a cure. And then what I'd really like to do is stand up in front of doctors and just share and educate them. So we have an open model, and it's a pretty new concept to have an open research model where you're actually sharing results. So we have on our website an area that researchers can actually go on to, sign up, and actually get the results, download them, look at them, and as long as they're doing research, they have access to that research, to those results. And we encourage other researchers to do the same because we want everyone, as many researchers as possible, to look at this data and try to figure something out. So on our scientific advisory board, we have 3 Nobel laureates, and we have 6 members of the Academy of Science members, and we have a huge working group now altogether of really top researchers from all over the world. Many European countries, Australia, Canada, many of countries are signing on board with us and meeting, and we have meetings to talk about what to do and to share results. So this really is a worldwide effort. I want you to know, and the reason I'm here today is to give you hope that there is a lot happening, especially the last 2 years. And so this is new. I mean, nothing was happening a few years ago. And now there's a lot happening, and there's a lot of researchers that are coming on board with us. And I just came from London, and we actually had 92 researchers at this meeting. And that is a lot. When I first started coming, there were 30. And so every year there's more people that are interested in this and looking at this and understanding that this is one of those big diseases that they should be part of if they want to be part of research. And we're really excited that there's much more research happening. This is a picture of our current scientific advisory board. And we are real excited about this and opening up our Harvard Center. So the Harvard Center is really going to do a lot of clinical work. And so we're going to do muscle biopsies and really do some pilots and clinical trials, where the Stanford group we've been working with are doing more of the molecular studies and looking what's actually going on and looking for a diagnostic tool, a diagnostic test. And then we'll be working with both universities together, along with the other researchers that we're funding, to have conversations to bring the clinical and the research together. So we're really excited that we were able to do that, and we just launched that last week. So we started this in 2012. My husband works behind the scenes and has really helped us develop this, and we work from Los Angeles. So we're based in Los Angeles, but really all the people that we work with and all the volunteers that we work with are all over the world. So we're an international foundation, and we now, as you know, we translate in, I think, 13 different languages now, so that way others can read what we're doing, and we want to share what we're doing at all times as much as possible to let you know what's going on. We have about 10 different research projects currently going on, which I'm going to go over and let you know what each one of those are. As you see, we've extended our programs. We have an open data platform. And the tour, last year we went, I believe, to 7 different countries. This year we're going from here and to Italy, and so I'm very happy to be here. It's our first time here in the Netherlands, and so we're looking forward to taking a look around the next couple days. We have a parent and school accommodations project, and as soon as we're ready for this, we will send it out to all of you on our database. In fact, I want to pass this around while I'm talking. If you're not already signed up to our database, if you'd like to sign up, you can go on our website and sign up at any time, but if you'd like to sign up, you can sign up here and we'll sign you up. If you haven't signed up in the last month, we need to have you re-sign up because of the new GDPR rules, which means you have to opt in. So if you haven't signed up in the last month, please go and sign up on our website and opt in, or put your name on here. We'll sign you up, and we'll just pass this around if you wouldn't mind passing it all around. Thank you. So the school accommodations is when the kids are not able to go to school, or when our daughter, who was 16, wasn't able to go to school, we didn't know what to do about education. And we didn't know what our rights were. And she was too sick, and we were her caregiver 24/7 to spend any time learning about what her accommodation should be. So we've prepared some information for parents to be able to take to their doctors and take to their schools, and we're just about done with it. We're just making it into a pretty flyer so it'll look nice. And then we'll send it out to everybody on our database and share it with whoever you like. And then bring it to your schools if you have kids that are in schools or colleges that need accommodations. It gives you what kind of things you might want to ask for your kids. So we're doing an outreach and also school education. We're going to be meeting in the United States. We're meeting with nurses for schools and trying to educate schools so we can help kids continue their education. In Italy, we're going to be talking to a lot of journalists, so we're going to go over some media coverage. But there's a lot of media coverage now, and so you see some things happening in some of the media here in Europe, and there's been a lot of articles being written in all types of journals now in the United States. So it's getting out there. Some of you, how many of you were involved with Millions Missing? Was it here in Holland as well? So some of you were involved with that. So that was in 100 different countries as well. And so there's a lot more media and press and discussions now happening more than ever before. So we want to encourage that. We want to bring awareness to the world as well. So we're we are excited to see that happening and encourage as many people that can write about it to write about it. So we're into collaboration because, as you can see, and especially here where there's so many bicycles, and it's great to see all these bicycles, no one goes anywhere if there isn't collaboration. So I love this picture. It kind of describes exactly what's been happening to the last couple of years. So we're trying to get them to go in the same direction. This is a picture of some of our working group at Stanford. And I like the quote, it's the long history of humankind and animal kind too, that those who learn to collaborate and improvise most effectively have prevailed. So we are trying to collaborate with as many researchers as we can and share results. We have a symposium coming the end of September. It's free and it's live streamed. So if you want to put this on your calendar, it'll also be videotaped because of the time difference. But you'll have that full access to it. We'll be having researchers talk, and we'll be having a 3-day science meeting beforehand that we're again inviting international cooperation from other researchers, as well as a community patient day on September 29th that you can tune into. And we'll put it on YouTube and it'll be live streamed. So getting into the science itself. And some of the projects that we're doing. And there's some projects that are really leading us to the next project. So what you hope to do is do enough testing that you get enough information to take you to the next step. And so we have our MECFS Collaborative Research Center at Stanford that's doing the particular projects that I'm going to go over first. And these are led by Dr. Ron Davis. He's our director of our Scientific Advisory Board, and he's also the director of the Stanford Genome Technology Center. He's a biochemist, he's a geneticist. He's one of the most brilliant people that could possibly be working on this. And we're grateful that he has brought on a whole list of researchers to work on this together. And the goals of the center are projects related to understanding and treating MECFS by developing and using cutting-edge technologies. Their expertise is developing technologies, and in this case, they're looking for a diagnostics and way to also test different treatments, and I'll go over that in a minute. So a couple of the 3 main projects that I'll go over a little bit later are T cells and molecular immunology that we're looking at. We're extending our big data study that we're doing in families, and developing blood-based diagnostic and drug screening technology. It'll make more sense as I go along. And then at Harvard, this will be led by Dr. Ron Tompkins and Wenzong Xiao. They are scientists that are working at the Harvard Medical School and at the affiliated hospitals at Harvard. And they're going to work in synergy with the Stanford group. And they're going to collect molecular data on muscle biopsies and body fluids and tissues and try to investigate what is causing the post-exertion malaise that the patients are feeling, and establish a clinical trials network so we can actually start doing pilots and look for effective treatments. So what the first study that we did as a foundation, the first study that we all did together, was a severely ill big data study. Some of you that follow it might have heard about it through the years. So we started this in end of 2014, and we took and went to 20 different patients' homes. We went to the severely ill. No one had really been studying the severely ill, and the scientists felt that if we looked at the ones that were most severe, we're going to find the most strongest biomarkers. So instead of drawing many patients, we decided if we look at the severest and do the most tests that we could possibly do, we will learn a lot, and we did. So we went to these patients' homes. We had 4 medical personnel go to each home. They tested body fluids and did medical assessment and did over 1,000 different tests. And we're now in the middle of analyzing all of that. All of our clinical results are up so that researchers all over the world can take a look at it, and we're sharing all those results. It's really being used as a resource for other researchers. They don't have to repeat that kind of research. They can take a look, see what we've done already. And we're examining the genome, the gene expression, metabolomics, the microbiome, cell-free DNA sequencing and quantitation, cytokines, and a lot of clinical laboratory tests. And what we're seeing is we're seeing a number of differences in the metabolites and in the microbiomes and in the cytokines, and differences in clinical test results. And what's really happening is these results are focusing on what to look for next. And so the other projects that we're going to talk about are because of these results. It's taken us to the next level, which was the hope, and that is what's happening. So they haven't found any new pathogens in the blood. Everybody is still looking for it. Is this caused by an infection? Whether it's caused by an infection or not, we don't know that, but it's not currently in the blood of severely ill patients. It's not currently in the blood of people that we have been testing and looking at. They're still looking at it to see if it's hidden somewhere in the body. So they haven't given up on looking for pathogens yet, but there's been nothing found yet. And you've heard that from other studies that have come out in the past. We take SF-36 scores, which are really surveys and self-reported scores of health status. And of course, it shows that, unfortunately, that patients that have ME/CFS are sicker than most other severe diseases. And the purpose of these kind of things are to show government officials and other doctors of how serious patients are with this illness. The genetics are showing a number of candidates that are showing predisposition to this. So people ask us, is this genetic? Can it be hereditary? We don't know those answers yet, but it's looking like there's a lot of mutations that are common in severe ME/CFS patients. And those particular mutations, they're looking at and seeing what types of, what are they causing and what is happening with that. And there's a number of information that we're taking from the genetic tests and looking at the metabolomics together, and it's leading us into one of the other projects I'm going to talk about in a few minutes. One of the other major projects we're doing is in the immunology department with Dr. Mark Davis and Laura Steinmetz at Stanford. And they're looking to see, is this an autoimmune disease, is this an infectious disease, or is this both? I mean, we really don't even know those answers yet. So what they are seeing is they're seeing what they call this activity in T cells. And this activity that they're seeing in T cells is telling them to keep looking at this because something is causing the T cells to act the way they are. So they're honing in on looking specifically to see if it's autoimmune or infectious disease. We call this the extended big data study in families because we're taking the testing and what we're learning from the big data study of the severely ill, and now we're taking a patient that's in a family and testing the healthy members of that family to basically see does this person look any different genetically or metabolomically or with the proteins? What is different about the person in the family that's sick versus the family members that are not sick? We're also looking at families that have multiple people in the families, and some of you know, and some of you are, and there are many people that have multiple people in the same family. We're also doing some studies on that. And again, we're looking at genomics and gene expression and the metabolomics of these patients to see what is different amongst family members. And the goal is to understand what genes are different or mutated in the person who is sick versus the family members that have similar genes and they're healthy. The diagnostic drug screening and technology development is very exciting at Stanford because it's giving us some very inexpensive tools to try to make a difference to find out, is a patient sick or is a patient healthy? And this will be eventually a way that doctors could analyze if a patient is sick or healthy when they're questioning there's nothing wrong with them, I don't see anything wrong with them with their normal laboratory tests. They'll be able to use, hopefully, some of these diagnostics to determine if a person is sick or not. So it's to optimize in clinical use to determine if a patient is sick or not, and we want to also use this particular technology to be able to test a certain FDA-approved drugs. Drugs are already approved in the United States and elsewhere, and what we can do is treat the ME/CFS cells with these drugs and then put them on these devices, and if they look healthy, that's giving us an indication that this particular drug might be worth doing a pilot actually in patients. So this helps test a lot of drugs very quickly, and it also saves millions of dollars by doing that, and you don't have to put it into the patients unless it really looks like it's something promising, and then we do pilots on promising results. This is one of the prototypes there's being developed. There's a few different types of tests and technology that's developed. This is one of them. This is called a nanoneedle. They're very, very tiny sensors, and they're sensing the current that's going through these. If I had brought one, it's about 1 inch by 1 inch. They're very tiny, and they cost about $1. And what they're able to do is when they put healthy cells on it, it has a certain current. They put ME/CFS cells on it, it has a certain current. But when they actually put the ME/CFS cells and the healthy cells in salt, they're challenging it. They're trying to mimic a post-exertion malaise type of environment where you need energy to kick the salt out of the cells. So what they found when they did this,
and they perfected it, was when they add the salt to the healthy cells, the volume, the speed, the current looks the same, and when they add it to the ME/CFS cells, it is significantly impeded, which means it slows down. So when they say that the impedance has increased, it means it's slowed down, and it is significant enough and diagnostic that you can tell a person is sick or is not sick. And this is the one that we can actually eventually add drugs to these particular technologies, and if it turns at making it look like the current is the same, then we can use that as an indicator to possibly do a pilot study on one of those drugs. Another project that we're working on is called red blood cell deformability. As you know, the blood flow in patients may be slowed down. The oxygen consumption, the energy consumption in cells is slow. So they're looking to see if it might be caused by red blood cells that are deforming. They might be going through the capillaries slower than healthy cells. So they're actually looking, and they see a difference now, and they're now testing more and more patients to see if this has anything to do with the red blood cells themselves and the flow of the red blood cells. We have a mitochondrial function test going on right now, just starting with a seahorse instrument, looking to see we're looking at activated T cells in patients compared to healthy cells and looking at the mitochondria. This particular project has just started. And as you can see, we're looking at different things. I mean, some of these things aren't even connected to each other. So we feel if we look at a number of different things, all we need is one thing to pop. And then we can move and go to the next project. So another one very important study that's just happening is called the metabolomic trap. And this was from information that we got from looking at the severely ill patients. One of the doctors, Rob Fair, he is a computational modeling expert, and he took a look at the results and saw a particular mutation in a gene that was all of the severely ill patients had, and about half of the healthy patients had. So it was a significant difference in this. And when he looked at it further, he realized that it was part of the metabolomics and the metabolomic pathway. And he realized and thinks that there's some type of trap that happens. And without giving you the technical details, they feel that if they can understand this trap further, they might be able to untrap this, meaning that this could be undone, and meaning that there could be an answer that might be literally just undoing a metabolic trap. So they're just looking at this now. They're looking at a couple of different traps right now, and this is a very significant test that they're doing at Stanford, and with Integrative Bioinformatics, we're collaborating with them. So stay tuned to the notices that we're sending out. We're hoping that something will come up with this soon. There was a metabolomics and genetics validation study that we started a couple years ago. This was to validate work of Dr. Bob Navio at University of San Diego, and he had found that in the metabolomics themselves, and the metabolomics are the study of small molecules, they're the sugars and the amino acids and the lipids, that normally when you go to a doctor and they draw your blood and they tell you, oh, everything's normal, they look at these certain metabolites, and they look at very common metabolites. And in most patients, the common metabolites are normal, and people look normal. But if they really look at the metabolites, and I'll show you a picture in a minute, there are over 1,000 different metabolites that could be looked at. And so they found many abnormalities in these other metabolites, mostly in the energy cycle, of course. And when they're honing in on that, they realized that the ME/CFS patients looked like they had a certain signature compared to other patients and healthy controls. So we OMF funded a validation of this. So they did another 132 patients with this. And the results of the validation showed 77% of the metabolomic pathway abnormalities were confirmed, and shows evidence that there could be a metabolic signature. And what that means is as we move along, if we find the problem is identified in metabolomics and the metabolites, we again may be able to tell which patients are ME/CFS and which patients are healthy from these signatures. So, not that I expect you to read any of this, but the blue shows a deficit compared to healthy, and the red shows a surplus compared to healthy. And if you could see a lot of blue and red in here. So when you look at a totally healthy person, not that anybody's totally healthy, but you might just see a couple of these. But in this case, there's 132 of these in this particular patient. So what they did was they honed in on these and took a look at what really is deficient, what is in surplus, what is going on in here. And so they're studying this, and so when you go to a doctor and they test, I don't know, 10, 20 different tests, and they say you're normal, they haven't looked at these other 1,000. So we're looking really deep into this, and we see a major problem in these systems. Again, proving that this is a biological disease. We're funding some research in Sweden by Jonas Bergquist and by Jonas Blomberg. And what Jonas Bergquist is doing is he was studying autoantibodies. We didn't find anything significant of autoantibodies in the spinal fluid, but they're finding significant autoantibodies in the plasma. So they're doing further studies on that. They're measuring also proteins and steroid hormones in plasma and the spinal fluid to see if we see anything different again in ME/CFS patients and healthy. But the autoantibodies are significant because we're also trying to see if they remove the autoantibodies, does a certain subset of patients get well after removing those autoantibodies? Those particular trials are happening now as well. We started analyzing patient data from doctors in the United States that are seeing patients. There's about 15 specialists in the United States that specifically see ME/CFS CFS patients. In all of the United States, there's only 15. So what we're doing is we are gathering the data from those doctors on what tests they order and what the results are of those tests, so we can do an analysis of what is abnormal on these patients and what tests the doctors order. When we get all that together, we will share that with everybody, and we will share that with the medical community to show what tests people that study ME/CFS patients actually use and to diagnose patients, and which tests are abnormal. So this will be a great resource for doctors that we'll be able to share, and we're getting all this information from the specialists that currently see patients. So we're into some other projects that we're not going to go over today, but there's other projects that are happening at different universities, and we are hoping to fund a lot of other projects as time goes on and give you another update soon. But Dr. Davis, he said, I think we can cure this illness. We're getting close enough to understanding the mechanism. Treating it would be okay, but of course we all want to cure it. Thank you very much.